Welcome back, everyone. In this video, we're going to discuss similar concept, but obviously from the Spark perspective, because what we are going to do, we will take our journey in parallel on both world, and I'll leave it with you. It really depends upon your organization or the environment where you are going to work, and they select the technology and they will let you know that okay, that's the technology stack we have, and you're gonna work with that technology stack. But trust me, with all these concepts, you can apply them seamlessly, or with very minimum effort. You can apply this concept in any environment, and I'm going to actually prove you in the upcoming videos that how one concept can be reused in all across database softwares or the cloud environment. So coming back towards this Spark is bit, I would say, a more complicated environment. Like the complication occurs because of the multiple options which are available, and the way Spark has been designed, because we are not used to with such syntax that we use into our script. So that's why people think that okay, that looks a bit complicated. But trust me, once you start understanding the mechanics of Spark, everything working seamlessly, and you won't face any issue. And the beauty is, imagine you are running your same queries, but underneath there is a big set of a cluster who's consistent of many nodes. There are many executors which are running your query load in parallel, so you can get the result as quickly as possible. Right? And that's something really changing in today's time, the way we are working with the data. So that's why the big data is not a challenge anymore, because we have such cluster that can partition the operation or the script, and then it runs in parallel and then collect the results and then return back to you. So if you look at, we are starting with Spark our journey in a same way. But before I explain this select statement in this Spark, I might give you a small intro to the namespace that we discussed yesterday, because I got a chance to actually open the Scala documentation, which is publicly available. You can go and you can look. So I just give you a quick brief that how you can trace and how you can extract the information, because once you start working with one set of technology, the only thing that you need to know the actual working pattern or the framework of the language. Once you are comfortable, then the rest is more like okay, that's the requirement, and that you just need to know what API or what functions are available, so you can apply those functions and you can start building the solution. Now coming back to uh, our select statement, everything is going to be remain the same. There's only one difference which I'm going to show you in the demo environment. So we are going to select all the columns with star, and we can specify the column name, and then obviously from statement is going to be same. We Instead of table name, we have the view name. That's where Spark is different from the pure SQL or pure database environment. And there is a reason. I'm going to actually show you why we use the view name instead of the table name. And obviously the where conditions are same. We provide the where condition, and then Spark will go and filter the data based on those where condition. So that's a very quick introduction to Spark. Now let me just switch back to my demo environment. And if I just stop my share, and I'm going to reshare. There we go. That's my machine. Excellent. So now what you can see in here, It's the same thing. Before I actually start with the Spark environment, let's have a look, a quick intro to how you can set up your environment. Obviously, like I mentioned, because I've already logged in, you can actually use that community.cloud.databricks.com URL, and as soon as you enter it, it's going to actually ask you the username and password, because I'm already logged in, so that's why it didn't actually show me the username and password screen. But in your case, once you open it for the first time, you will see the login screen. Feel free to register if you don't have the existing login. There is no charges, and it's not going to actually ask you for your credit card. But in return, once you register, you're going to get the 15 gig cluster, I think with one node, because by default that's the minimum they provide you, but that fulfill most of our need from the learning perspective. And as soon as you get the job, tell you the truth, all the cloud providers, whether it's going to be Google, or it's going to be Microsoft, or it's going to be AWS, all of them have the DataBricks integrated, and you can use them. And even, you know what I'm going to do, let me just show it to you. Yeah, too much talk. Yeah, I'm not going to use it. So you can see with Azure, I can go and I can create the Azure DataBricks. Obviously, my now subscription is pay as you go. I'm going to use my and I'm going to use X tab. I'm just copying it. Right, I'm keeping it in the US, and you can see pricing tier Apache standard. Let me see if I have. Let me use, yeah, 40 days. Let me just start with the premium, which is the 40-day free trial, and then I will delete it because I don't want to pay. Yeah, we are not going to with secure cluster connectivity. That's more like, you know, networking and security perspective, which our infrastructure team look after, and they make sure that the configuration from the network perspective is correct. Obviously, we are not going to deploy it into our own virtual network. Again, that's part of the infrastructure team role. They decide where they want to keep that instance. And guys, keep in mind that most especially once we work in the cloud, we work into a team environment where obviously our infrastructure team, they are looking after the whole infrastructure, and that requires that includes a big component of networking, and our job is actually use that infrastructure to build the capabilities. So that's where the agreement is. Yeah, enable infrastructure encryption. I'm not going to do it anyway. It's not available because I'm using a free account. Tag I will definitely provide, because that is going to be the type, and I'm going to use the dev and test. So all good, and I'm happy to create it. So validation has been succeeded. It checked that all my entries are correct, so it's going to create it. Now, let me come to my AWS account. What I'm going to show you, I'm just going to show you DataBricks. Okay, now I'm looking for the service, not like. So let me see. I think it must be in here. Here's my all services. Here's a one. Let me see if I can. Must be in here. Okay. Okay, for somehow, let me see if I can, come back with the back to the AWS. What I can do, I can show you in here. So that's my Google account. So I'm disappointed that why I wasn't able to find the DataBricks, because the DataBricks should be available straight on the menu list. Because I'm gonna show it to you. Look how the Google has arranged the services. One thing, guys, remember that we are going to use all these services on all these cloud platform, so you can get the idea that okay, whatever cloud environment you are using, they work seamlessly on all these cloud. And especially once you understand the lake concept, I mean, you understand the database concept, using any cloud technology is not going to be a big issue, because the concept is the cloud vendor is managing the infrastructure and the environment, and all you need to actually build the capabilities for your business or organization. So whatever skills you have, the beauty is you can seamlessly translate, or with a very I would say slim learning curve, you can actually migrate your skills from one cloud platform to another cloud platform. There we go. We have the DataBricks. So let me come in here. 14 days trial available. I'm fine. I'm going to create a 14 days trial, because later on, like you can see, the terms and condition is almost similar against different cloud platform. You can see it is charging me DPU 0.20 and my billing account. Yeah. So I'm going to select the plan. No, it's already, yeah. Free estimate 1 year. What if I just cost? Let me see, 2.52 years. Let's use at this stage only these two, because keep increasing the cost. And I have some pre-budget. If you haven't got your account set up, you can go and you can set up the Google cloud platform account. All it requires your email address, valid email address, and valid credit card. I'm going to discuss it in a separate video. I don't want to confuse it. Yeah, I'm all good. So let me subscribe it. And now it's going to actually process my request. Let me come back in here. So my deployment is done. And let me show you. Okay. So I'm on the trial with 14 days free DVU. Let me just open my DataBricks instance. Now that DataBricks instance is not the community edition. So it has all features that we are using in here. But the difference is it has more powerful features, and it has more capabilities that we are unable to see within the community edition. Like we can add more cluster, we can increase the nodes within the cluster. So all these capabilities which are not available or which are limited in the availability in the community edition, they are not applicable in the actual cloud provider environment. So I'm going to build the pipeline at the moment. So let me finish it up. So you can see now everything is same. Like in here, you're gonna find some rare difference within the two environments. So now look, that is the community edition, and let me show it to you. That's our actual edition, which has been integrated with the Azure platform. And guys, have a look in here. We have another similar environment. Within we have similar environment within the Google cloud platform. So you won't even see a minor difference. There is a full infrastructure which is running underneath, which is hiding all the complexity of the integration and the configuration of all the DataBricks on your behalf. All you need to do the same thing, spin up your clusters, create your database, and start writing your notebooks or script, and everything work. And the beauty is, if you work in one environment and you want to shift into the other environment, the only thing you might need to change the service address, and the rest of the thing will work seamlessly. And I think we'll do that experiment sometime. So that's the introduction to the DataBricks from the cloud platform perspective. Now coming back to our first script that I have discussed with you, we are going to write our first select statement or first selection using Spark. But before that, like in yesterday video, I mentioned you that never ever scared of these, you know, fancy import statement, because these are nothing but more like the hierarchy of the namespace, or you can say packages. And today when I was exploring the documentation, you can see the top one. If I just click on in here, we have the top package called org, and then underneath you can see on my right hand side we have the hierarchy. We have Apache, and then the Apache, we have two packages. One is Parquet. Parquet is the data format that has been extensively used in the industry now, especially from the big data perspective, and especially if people are using Spark. And you can see Parquet and Spark is available. So, up to this point, we normally think, oh, there must be some fancy thing which is happening, but there's nothing. It's more like, a namespace that we have to include if you want to call the function or the classes. A typical programming concept, if you understand the object-oriented programming, or if you learn any language, programming language, you can understand the concept of, creating the namespace and putting the classes within the namespace, because that will manage the code nicely, because we have thousands of classes available in Spark. And if we just dump it into one package, it's going to be very hard to manage it. That's why we always have these hierarchy that will help you to locate the right functions or classes quickly. So for example, now look, if I want to go to SQL, because I'm using SQL a lot into my Spark notebook. So you can see we have under Spark, we have another package called SQL. Let me just hit on it. And now under the SQL, you can see we even have further packages or classes. So, and on your left hand side, you have the details of these the details of classes and the methods which are available in this package. Let me just pick one. So for example, let's go towards the function, because we're going to use function a lot. So in the function, you're going to see we have all these functions. We are going to use the count. We are going to use the average. So count is actually calculate the total number of records within the data set. It will return the total count. So I'll revisit this documentation later on, just to show you how you can learn the language. Once you understand the basic, how you can extend your knowledge. Once you get on the job and you look at the requirements, okay, these are the requirements I need to build. So sometimes there are gaps which you need to find out. Okay, the business is asking that I want to see the total number of records. So which function in my Spark library that can return me the total number of records of my data set? So if we come in here and we look at count, aggregated function, return the number of items in a group, and that group can be a data set, or that group can be a list or array. That's why they are not mentioning a particular object in here, guys, because we are talking about Spark as a language. Although we are going to use it for our data and analytics work, but theoretically it use the similar concept against other objects as well. For example, list, and for example, the arrays or structure. So every other concept follow the same pattern. Enough introduction, enough theory. Jump back to the practical. So now you understand why I have actually imported the org.apache.spark.sql, because obviously I'm going to use some of the functions which are part of this package again. So in the function, we recently have seen it. Now we have two ways to include the part of the package or the class. We can either put the braces, curly brackets, and then we can put the function that we want to include. Because normally if we won't put anything, it will bring all the classes or all the I would say members, which sometimes is not very efficient way, because then the runtime needs to load these functions and memory into the memory for the evaluation. So first thing, like I can mention count, I can mention expression, I can mention average. So there's a bunch of function that we can see in this documentation here. You're gonna find all this. So you can see average must be the average in here. You can see average in here. You have the count, you have the correlation, blah blah blah. There are many functions, right, which you learn over the time. Or if you don't want to specify the function and you want to include all the function, you don't want to bother that. Okay, I don't want to remember everything. Just put underscore, because underscore will bring everything for you. You don't need to mention any particular one. So just ignore this statement. I'm not going to use it in this one. By the way, always confused, because once in your head you have multiple languages syntax, and you're always confused with these things. If you want to see which is the default language of your notebook, so you can see on the top, my default language is going to be Scala. So if I don't mention the language which I'm using to build my code in the cell, whatever language is the default, that language is going to be used. So that's why whatever I'm actually building, that will be compiled and translated against that language. So you can see there's another indicator in here. You can see the language is Scala. You can change it to any other language as well. And we have seen that yesterday that we have 4 languages available, and you can see Scala is the default language. By the way, once you create a new notebook, you can select the default language. If you don't want to use Scala as a default language, you can change it to Python. If you don't like the Python as a default language, you can use the SQL. And if you don't like the SQL, which I hardly believe, because I believe you love SQL, you are going to select R, which is another analytical language. I'm not going to change it. By the way, there's another way to change it. If you can come in here, click on the top on the language section, you can change to any other language. There are multiple options to change the language. Now, the next statement is the similar one. Like yesterday I mentioned, we have the data set available. These data sets can be on our local storage within our cluster within the DataBricks environment. And I think that's where DataBricks is really gaining market share with many of organizations, that it provides you the full environment to build this solution that include the data storage, that include the notebook development, and that include to even create the database, as well as the machine learning and streaming capabilities. So imagine everything is available under one umbrella. You don't need to go here and there. Everything is available. You just need to use the platform, and it will provide you all the capabilities. Looks cool, huh? So the very first thing that we are going to do, because right now we are moving from typical query environment towards the environment which provide the query capabilities as well as the programming capabilities. So if you remember, I told you that we use WAL. or val, whatever you want to call it, to declare the variable. So whatever comes after the val, that will indicate for Scala compiler that that's the variable. And obviously file location is referring to the path. So that's the file store, which I mentioned, the storage structure. And by the way, the DataBricks use the Linux specs storage structure. The server's environment is Linux based. In one of the video, I'm going to actually show you how you can actually manipulate and how you can get the information about your storage using the Linux command. Like you can run ls to list down the directories, and there are DB utils that will provide you, further capabilities to investigate the operating system more. File type is going to be CSV. Infer schema, if you remember, I told you that infer schema will automatically assign the data type to the column name if we based on the values that have been stored. It's not a recommend normally in the real environment, tell you the truth, because we don't want to let the system decide the data type, because most of the time, tell you the truth, it assign a wrong data type, right, which we want to change it. So it's better to always keep it false until unless our system is so clean and straightforward that okay, DataBricks is going to allocate every data type 100% correct, which is almost impossible. First is the header. By name you can see, and we mentioned, because most of our data set which comes into the CSV, our first row is always indicate the row header, so that's why we put it as a true. And last but not the least, our delimiter is going to be the comma. If you are using pipe sign, feel free to use pipe sign. If you are using semicolon, use semicolon. Whatever delimiter you are using, you can actually use it in here. So by the way, if you get any error, it's going to actually display an error, and you're going to see the red sign on your notebook, which refer to the cell and the line, and you need to fix it. And then you're going to see the error description. Now we enter into the first step of running our Spark statement. Spark is all about, especially from the data and analytics perspective, Spark is more like, linked with the data frame. In a simple word, what data frame is for us is more like a tabular format, which has some rows and columns, but underneath there is a lot of advanced technology. RDDs, what RDDs are, how they work, that's something we can park for another video, because that requires its own video to be discussed. But in short, that under your data frame, there is a big structure that has a capability to scale across multiple nodes within a cluster, so it can increase the efficiency. So now imagine if you have literally million or billions of rows, and you want to load and process into your data frame, you have these big clusters available for you. They can partition the data, and then they can distribute the load across these nodes within the cluster. And then once the process has done, the results have been collected and returned back to you. And that's where it is really different from the database environment. Within the database, unfortunately, we don't have this sort of capability that on runtime we can split our load and distribute, and that's why it's called distribute programming, or distributed processing, where our load has been split and then distributed into different nodes. Spark is a universal object that we can use without any reference within our data bricks, and then it has the read function or read class, whatever you want to call it, and read class has further options, which obviously mention the file format, and there are multiple options. So these ones we will see in a separate video, because that's a very important statement. With read, you can read all kind of formats which are available. You can read the CSV, you can read the JSON, you can read the Parquet file. The beauty is everything is going to be loaded into the same data structure, which is obviously the data frame. And sometimes the beauty is you can actually retrieve the data from JSON data set, and you can store back as a CSV, or as a Parquet file, which really transform the data from one format to another. And you don't need to anything, you just need to issue the read and write command, and then Spark will do everything for you, or on your behalf. So you can see in first schema, I've already declared the variable, so I'm just passing into the option the variable that I've declared above. And then at the end, I'm just calling the load statement. Load statement is more like the indicator. Okay, load that file, wherever that file is, and obviously that file location we have already mentioned. Is it our cluster data storage, which is file store / tables? That's the location, and we have our file available there. So as soon as I'm gonna run it, you will see Spark job is running, and that's gonna load it our data within our data frame. Now, like I mentioned, data frame is a table or two-dimensional structure. So that's why it has a schema. And schema is more like the columns and their corresponding data types. So you can see we have all these columns available within our data frame, and these are the corresponding data types. And there is one more thing, guys, you can note, which actually link it with the database. You can it is mentioning that which one can be nullable or which can be not null. So once we create the table within the database environment, we mention that, okay, these columns can have null values, or this column doesn't have the null values. So these are the similar capabilities which are available within the data frame. So on one side, it is overlapping the database table structure, but let me put this way, it is way more than the table structure, because the data frame handles the semi-structure or unstructured data as well. All right, so we're good with our schema. It is very similar to the one that we have previously seen into our SQL. And just as a reference, let me just quickly obviously we have more constraints and more properties described on our table. I'm not going into the detail, just showing you the columns and the data types. Obviously, these are something that has been developed within the database environment. Ignore that. You can even consider them as a string. So in here, you can see they're all treated as a string. One thing, if you note down, it is giving string data type to modified date. So for somehow, it is treating the modified date as a string, which is obviously a challenge. We might need to later on convert that data type into date type or timestamp, and then we'll update our data frame. So that's something we will do it as an exercise. But right now, so our data frame has been done. Now I'm going to show you something that really make you happy, that how we are going to reuse the similar select statement that you have seen on the slide within the Spark environment. So what happened? Once you create the data frame, you have the opportunity to convert that data frame into a virtual table or a view, and then you can apply all the SQL language on that view. So for example, if you are not very proficient within the data frame, initially you are relying on the SQL to get started with Spark or DataBricks. Don't worry, everything is gonna be the same, because there's a full SQL API that has been developed DataBricks, and you can do all those operations same way like you are doing with the DataFrame. Obviously, DataFrame has some more capabilities which are very advanced. Once we reach there, I think by that time you're gonna have that experience that you are fully comfortable with this parsing syntax. So then we can use the data frame instead of our virtual table. But I think at this stage we are fully comfortable. We can create or replace our table into our data frame into a virtual table or view. That's why I called it VW, because you can see it's going to be create or replace temp view. This view is going to be local. It's not going to be available into other notebooks if you want to use them or anyone else. But if you want to use the global one, there is a command to create the global view as well. So my view has been created. As usual, I'm going to run my first statement. That's the whole point of this video. I'm going to run the very basic select statement. Let me just take this one out because that is different. One thing, guys, you can, if you want to, if your default language is different and you want to run a particular cell with an other language, you need to specify the language after the % sign. So you can, so for example, if I'm using SQL as a language of this cell, I need to put % sign and the SQL. And if I'm using Python, I just need to use Python. And then compiler will automatically evaluate the statement based on the language that has been defined after % sign. But this is the SQL. So I'm just going to use, so you can see as soon as I change the language, the syntax color has been changed, because that is now indicator for the compiler that that's a SQL statement. So you can see we have received 1,000 records back from the DataBricks engine. And one thing, remember, because we are working within the web environment, so that's where the flexibilities are different. Like you are not gonna get all the records if you want to retrieve it. Obviously we can adjust these settings, but there's no point for me to return all the records running the plain queries, because obviously in data and analytics we have a different kind of, we normally extract the aggregated information which we can use for the analytical activities, but that aggregation built on millions or even billions of records. What I'm going to do, I'm going to do a little bit different. I'm just going to show you how many total records, so we can match it with the, by the way, if you want to run any cell, you just need to press shift enter and it will execute that run. So we have 1026 record because we have extracted that file from the cloud-based database. So let me quickly cross check against my cloud-based database. So that's my cloud-based database, and if I come in here and you can see 1026. The total number of records has been mentioned as 1026 records. Cool. So the records are matching. We have a similar data set within the Spark and within the cloud-based Azure SQL environment, which is good. Now here's a small twist. I know that we are working within the SQL environment. For example, imagine if you want to generate the similar outcome from the data frame. So imagine, like I mentioned, both APIs has been built, and they provide the similar capabilities. Like for example, if I'm getting the records from the SQL statement within the Spark, I can generate the similar information using the data frame as well. And there are methods available. Like today we are discussing Slack, so we're going to actually see what information I can use to select the data from my data frame. So let me just change it back to the original one. One more thing that I would mention. If you want to limit the number of records to return, so you don't want to return the full data set, there is a clause that can limit the data set, and that is the limit, which comes at the very end, and it will specify once the engine return us the records, how many records it should return. So in our case, I'm just asking 10 records. So that should be all right. See, now that's what I was actually talking. Whenever there's an error, you're gonna see a red message on the top right on your screen, and it will show you, okay, there's an error running command, go to the command, and we are in that command. Okay, what we are saying, oh, there is a total. That's good that we have encountered that as well. Now let me just run it again. So all good. We just put the wrong word in our SQL statement. So all the data is good. We only getting, just quickly show you, we're only getting 10 records because I have limited to 10. If I just limit it to 100, and let me run it, let me quickly show it to you. You can see we have, let me just go in here. We have 100 records returned from our SQL. Now, if I need to build the similar capabilities using the data frame, so for example, I'm now that's where I'm actually shifting from SQL to Scala, which is the actual Spark environment from the language perspective, right? So imagine in our SQL we have the temporary table or view that we are using to run our queries. But as soon as we come towards the Scala, the language of Spark, we have the actual physical object, which is the data frame, which is containing our data. So the command is the same, like you can see, and once we are familiar with these commands more, then I will actually go and I'll show you the semantics of the command, that, or you can, how you can read the syntax of this command. Because once you start understanding the syntax, you will never be afraid of Scala or Spark anymore. You can understand, okay, all this ugliness of the syntax is just part of the language, right? But underneath, it's a very similar concept as of other languages. By the way, we're going to look at the Python PySpark as well, which is the Python based version of Spark, which is encapsulating a lot of complexity and just giving you the wrapper. So you just need to call those wrapper, which are Python based, which is very nice and clean, instead of a Scala based. But obviously, if you understand Scala, why I'm actually emphasizing Scala, once you understand Scala, you actually know the original language of Spark, right? So that will obviously more powerful than using the wrappers. All right, coming back to my data frame. After the dot will actually provide you all the functions that are available. Let me just show it to you. So once you press dot, if nothing comes up, you just need to press a control and tab, control and space bar. It will show you all the methods which are available against that particular object. And you can see it has all these objects: describe, drop, dtypes, input file, a lot, map. We're gonna see map, join with, limit. And right now what we are using select statement. So select is there as well. Select is used for selecting the information from the data frame. And obviously in the parameter, brackets, you're gonna pass the parameters, and what can be the parameter, obviously the column names, right? So what we are doing, try to understand this statement. We have a data frame, we are selecting the information, and we are passing the parameters which are going to be the column names, right? Which is more like, what we are doing, we are writing select and star, which provide us the which indicate that we need all column. And then instead of from and the table name, we just have our data frame. And then obviously in here we are using limit. With the data frame, we have another method called the show method, which limit the number of rows that has been returned. And by the way, these functions which we are calling, they can be nested. So you can nest your statement as much as you can, because the same way we create the query. So we are creating the query, but in a very different way. Keep in mind that we are doing the same thing, but the world is changing, where we are shifting our focus from query language towards the programming language side, which I know for many people is a bit complicated because they are so used to it with this SQL. But for you guys, you still have full opportunity. If you don't like it, just ignore it, and you can still go your way, and you can write your statement, and Spark will handle everything on your behalf. It will just use your select statement, and it will convert it automatically into the corresponding data frames, and the respective clauses that or function to be attached to that data frame, and run it on the data set to return back to the result. Coming back in here, now we are going to return 10 records, and we are going to, like I mentioned, all the columns. So let me run it. Cool. So you can see same output like we have up there. So the only thing we are running, we are returning 100 records. So you can see, you can even match the column. You have Ken J Sanchez, we have Ken J Sanchez, we have Terry Lee Duffy, we have Terry Lee Duffy as a second record. So the output is consistent. Let me just add just to match 100% both rows. Now you can see in here, with this one, it is only showing us top 10. I think that's the sorry, not this one. That's my bad. I went to the wrong side. So we have top 100 rows that has been retrieved. Now, the second statement, obviously, as a next step, what we're gonna do, let me just add a cell in here. You can just click on that plus to add a cell. Now, instead of all the columns, I'm only interested, for example, first name, last name, right? Again, limit is 100. So instead of returning all the column, I'm just returning the same. Now, similar way, you can see in here, all I have changed the part that I have changed in the SQL statement. So instead of returning all the column, I'm just returning these 3 columns. So the results are again similar. Now here come the last part of the syntax diagram. We are going to filter our record. So let me just put my first, and let me just copy. So what I'm going to do, first let me show you that I'm going to, and there are multiple ways you can format your select statement. It really depends. So I'm going to now put, so you can see here, we are exactly matching our SQL statement that we have previously run against Azure SQL. So now I'm going to filter on person type, which is going to be SC. I think it's double quotes. Yeah. Always confused with these quotes because I'm working in. Yeah. All right. So the only thing you can see I've filtered now, I'm going to return those records of person where the person type is HC. We have showing all 100 rows. I think we have more than 100 rows, but it is returning first top 100 rows. Now, if we want to change the, if we want to apply the similar concept on the data frame, so now look, everything remains same because now we are adding the where clause. So in the data frame, we have the where statement available as well. Like you can call the where function and then you can pass the condition within it. Now, how that statement has been read, in the where function, you need to mention the column name, but in where function, you cannot pass the column name directly. You have to use the call function that will actually get the column name and return the actual column from the data frame. So understand this. In the where clause, but in the where function, especially from the data frame, if you want to pass the column, you need to use the call function, and that's where the Spark seems to be more complicated than any other language, because it's a very type language. You have to follow all these patterns that has been built, and these things make it more complicated. But once you understand, it's not gonna be complicated anymore. So column get the column name. So in our case, it is the person type, and it's going to actually return the actual column, which we are going to compare. And you can see, we can even use, what I can do. Let me just do one thing in here for you. Yeah, I think that will work. Yeah, let's see. Oops. Oh, what is saying? Okay, it's saying cannot be applied to dot where. Yeah. Okay, that's the syntax error. So the error was that it was unable to recognize the equal sign, especially the comparison sign. You remember, if you know the Java or C and C#, we have the double equal sign which we use for the comparison. And if you remember my initial discussion, I mentioned that equal sign has been used for the comparison, which is obviously return us the logical result. It's going to be either true or false. So now in here you can see person type is going to be SC. We are only returning those person where the person type is SC. Now, so that's a first way, because especially in the programming world, we always have multiple ways to do the similar things, right? So that's the one thing. You can actually compare a value against the column. However, if you wanted to go more like a formal way, then you have another function available. You can nest it further, and you can actually call the equal to, and then equal to receive the value against which you wanted to validate. So for example, you want to see whether the person type is equal to SC. So equal to will provide you that capability. Then you're going to get the similar result in here. You know what I can do? Let me just take out this statement for a while so we can see at least whether we are going to get the similar results or not. If I just comment the dot show, it's going to return me all the results, which I'm fine. I can, so where it is. Okay, select. Okay, it has returned, but I have to, yeah, it's the statement has executed successfully, but I have to return the total. So what I'm going to do, I'm just going to use 1000 because we can display 1000, right? So you can see we have the total number of records. Uh, should show it in here where my total number of records are. Okay, it's not actually showing us, but we'll find out how we can show the total number of records. Let me just come in here and do the same thing. There are multiple other ways to get the total number of records. It's not showing me how many records it is retrieving, which is funny. Theoretically, it shows all the records, but in for somehow it's not liking to show. Anyway, let's run this one as well. Yeah. But what we can do, we can actually too fast. So both are returning the same result. Like you can see, we have first name, middle name, last name, and even you can see by a quick, eyeballing, you can find out that there is no difference. So both data sets are returning similar records. Why it's not showing the total number of records? We'll see it later. But that's something. Now have a look what we have done so far. Very simple. We run the select statement with all the columns. We run the select statement with the limited column. We apply filter on the column as well as on the row. So that's pretty much it for the Spark. I know our Spark lectures are going to be longer because we need to discuss lot of concept, because I think discussing the queries are easier compared to discussing the Spark notebooks. So thanks for watching. If you have any question or if you want to discuss anything, feel free to put the comment. If you like the video, please like the video, and if you can, please subscribe the channel. Thanks for watching, and I'll see you in the next video.